Given this triangle, 3 points PQR, write the equations for the perpendicular bisector for the three sides. Show that they intersect at one point C called the circumcenter. C is the midpoint of PQ. What kind of triangle is PQR? This problem is inherently harder because there's a lot of stuff going on. We need to make sure we label this material clearly that we can see what's going on. So we're not going to graph this. We're going to sketch it. Do a quick sketch. Remember, my definition of what sketch is in the books are two different things. The book doesn't think you can actually draw a graph. My sketches, you're going to have just something quick down. We have 0, 4. We're just putting there. 8, -2, and then 7, 5. So we have P, Q, R. This is going to be very important that we have everything labeled well, though. So let's pick one of the sides. We'll just start with PQ. Let's find the perpendicular bisector of PQ. So the first thing we're going to do is find the midpoint of PQ. Remember, that would be the average. 0 plus 8 over 2, 4 plus -2 over 2. So this gives us 8, 4, 1. And now we need to find what? If it's perpendicular bisector, it's going to be coming out something like this. So it's going to be perpendicular to PQ. We need the slope of PQ. We can pick either one to be the x2, y2. -2 minus 4 over 8 minus 0. Now normally I start with the other one. I'm just doing this one just to make sure that you see an example. It doesn't really matter though. -6 over 8, so we get -3/4. We don't want -3/4, we want the perpendicular to there, so we'll have 4 over 3. Now the equation of this line, we're just going to plug it in. Y equals, or no, not y equals, y minus 1 equals 4/3 times x minus 4. Now it's going to be easier for us when we get to part B, show that they intersect at one point, is to put this in standard form. And since I haven't done that yet, let me take the time to do it right now. How would I go about putting this in standard form? Remember, standard form is ax plus by equals c, where a, b, and c are integers. So in other words, we can't have this fraction here 4/3. What could I do to get rid of this fraction? I can multiply every single thing by 3. So if I multiply this side by 3, and then this side by 3, I'm going to have 3 times y minus 1, or in other words, 3 y minus 3. The 3's will go away on this side. They reduce out. So now I'm left with 4 times x minus 4, and I get 4x minus 16. Let's move the 3y to this side and the 16 to that side. So we'll have 4x minus 3y equals, add 16, so we get 13. Next one, let's do QR. What do we need for that one? We need the midpoint of QR. Once you start getting it down and seeing what you need, it can go a lot faster. So we have 8 plus 7 divided by 2, -2 plus 5 over 2. But the only way it's going to go faster is if you know what these words mean. That perpendicular bisector, what are we finding? That midpoint, and then the perpendicular to that side. Similar for the altitude or the medians, once you know what you're looking for. So we'll have 15 over 2, comma, 3 over 2. Now let's find the slope of QR. 5 minus negative 2 over 7 minus 8. And I'll get 7 over negative 1, which is our negative 7. Now my perpendicular slope for that would be positive 1 over 7. Plug that in. Y minus 3 halves equals 1 over 7 times the quantity of x minus 15 halves. Now, what would I multiply by that will get rid of all those fractions? I definitely have to multiply by a 7, and it looks like I should probably multiply by a 2 as well. So let's multiply by 14 this time. So we're looking at 14 times there, and then 14 times this. So I'll have 14y, and then 14 times 3 over 2. The 2 and the 14 will reduce to 7, and then 7 times 3 will be 21. 14 times 1 over 7 is 2. 2 times x will be 2x, and 2 times the negative 15 halves will be negative 15. Let's move the 14y to the other side, so we'll have 2x minus 14y, and then the 15 over here, and I'll get negative 6. Now, just to tell you why do I want to move this stuff to the right side, is because my x value was positive on both of those, and I want to try to keep the x's positive. Now, if you notice here, all these are even. We could divide everything by 2, which means when we first multiplied by 14, we really could have gotten by with multiplying by 7. But it doesn't make any significant difference. So now we have our next equation, and then our last one. So we have PQ, QR, so we need PR. Find the midpoint of PR. 0 plus 7 over 2. Make sure we're looking at the right numbers. It's easy to make a mistake there. Then we make this, find the slope of PR. 5 minus 4 over 7 minus 0. So I have 1 over 7. I want the perpendicular slope, so it's opposite in sign, and then the reciprocal of 1 over 7 be 7 over 1. Plug this in. Y minus 9 halves equals negative 7 times x minus 7 halves. Now it's your choice. On the previous one, when we multiplied by the 2, since we had halves on both the x's and x and the y's, it didn't really need it. Here, if we multiply by 2, we'll get rid of the fraction immediately, and that might be easier, or we could try multiplying by 7 and see what happens. I think I'll just multiply it by the 2. We'll have 2y minus 9, so we'll going to multiply this by 2, and I'll multiply this by 2. So we have negative 14 times x will be negative 14x, and then negative 14 times 7 over 2. The 2's are going to reduce, and I'll be left with a positive 49. This time the x is negative, so let me move that to the left side. So I'll have 14x plus 2y, and move the 9 to this side, equals 58. Again, I have all numbers are even, so let me divide out the 2. So I have 7x plus y equals 29. Now I have 3 equations, and I need to show that they intersect at one point called a circumcenter. Remember, and this is another thing George would tell us, have we ever solved a similar problem to this? And the answer is yes. In section 1, we had 3 equations, and we said, how do you find, or how do you show that they intersect in a point or not? We can take the 3 equations. Now we're going to deal with part B. And I'll write them down. I have 4x minus 3y equals 13, x minus 7y equals negative 3, and 7x plus y equals 29. You can pick any of the equations, any two equations, we'll solve that system, and then we'll check it in the third one. Which one do you want to use? The only one that stands out to me is either the second or the third, since those have simple values, one of them that has a 1 in front of the x or the y. So we could start with this. The last equation here has a 29, which is not as nice, but let's see how that goes. Let's get rid of the y value. So if I get rid of the y value, on this bottom I'm going to multiply by 7. Well, that's going to be a little bit harder since that's a bigger number, and the top we'll leave it alone. We'll see what we get. So I multiply by 7, I'll have 49x plus 7y. Now I don't have a calculator. I could do 7 times 30 would be 210. And then I want 1 less 7, so it'd be 203. Add them up, I get 50x equals 200, x equals 4. Plug it back into one of the two equations and find out what the y value is. I'm going to plug it into the second one. So I have 7 times 4 plus y equals 29. So that's 28. So y is 1. Now I have this point 4 comma 1, and I need to verify, does that actually work in the third equation? So that will be 4 times 4 minus 3 times 1. Does that equal 13? 16 minus 3 equal 13. Yes, that checks out. So we verified that that point, and this point 4, 1 is called our circumcenter. Now what kind of triangle is PQR? Well, and now if looking at this, let's come back to our picture. Now it turns out that this midpoint, it goes here, and that is our right angle. When the perpendicular bisectors meet at the midpoint, we could go through the geometry of it. So let's see, this is going to be a midpoint. This is congruent to this one. These are right angles. Remember, this is congruent to itself. So these two triangles are congruent, which means that this piece is congruent to this piece. So we're guaranteed that this is an isosceles triangle, but there's something else that's going to be true as well about this. Do you remember what that would be from your geometry days? It turns out that this angle up here is also a right angle. That this triangle, this piece here that has the 2 marks, is going to be congruent to this one. And I can go over all of that in class. So it turns out that this is an isosceles right triangle.